Assalamualaikum warahmatullahi wabarakatuh. To everyone, again we see you in this section. For the next topic, we have the next chapter, which is chapter 6. Let me just share screen here. Alright. Okay, for the chapter 6 in the instrumentation for process control on the industrial communication system. Okay, again, the credits of this lecture notes will belong to Dr. Wahyu. Okay, this is the final chapter, or what we call it as a complementary chapter to the instrumentation and process control. We will only briefly look into this section about communications, communication, or more precise, industrial communication system. All right, for some subtopic for this chapter include, first we will look the principle of interfacing between the input output, between the communication between two platforms, right? Principle of interfacing. We will look at the field bus system, instrumentation, network design, and profit bus. Okay. All right. Principle of interfacing. Okay. So basically, by looking at this figure or illustration, we can see there are control unit or supervisory system. If you can see here, to control the device at the remote area. We have some device at the field, and how this supervisory system is to communicate with this one is by using the communication system, which in this case we call it as a field bus, to connect between the control system, control unit to the access device at the field. Okay. Interfacing of a digital control system. Interfacing of a digital control system consists of, first, physical layer. Number 2 is the communication layer, and number 3 is the parameter classes. Okay. First, physical layer. Okay, we have the physical, the various topology and type of data block used by the foundation field. It means that we have the physical layer here, which is we know this supervisory system, PC, and all relevant equipment is attached to the device at the field. And then next we have a communication layer, how field bus use and assign the device register, how the field bus going to notify or to communicate between the device and the control system. This field bus need to ensure that all the digital data is being transferred to the end output, to the end output of the at the field. How field use and assign device register. Register is mean all the binary bit. 10111 sorry 10111 1110112 that binary number. Okay, and then the parameter classes, the function of roles of the information generated on the network. Okay, the classes, what are their category? Okay, we have, in this case we have 3 categories parameter classes. First is the supervisory system, and the category 2 is the field bus, which is communication system. And then we have the device at the field. That be connected to the supervisory system. Okay, principle of interfacing. The best example, that the one that commonly been used in practice in many power utility company is a SCADA. Okay, SCADA is a supervisory control and data acquisition system or structure. This will consists number of RTU, remote terminal units. Okay, collecting field data and sending that data back to the master station via a communication system, field bus system. Okay, the master station display the acquired data and also allow the operator to perform remote control. The required control action are conveyed back to the process. Okay, what happened is that in the SCADA system, just like this one, okay, just like this one, this representation. Okay, what happened, we have the sensor or RTU, remote control, remote terminal unit, or the device at the field, or the sensor. These are connected to a PC, quote unquote PC, or in this case is a SCADA, as a brain, as a control system, to acquire data from the RTU, which in this case they are all sensors, and then this data to be feed back to the control room, and the control room will feed the signal to uh, the RTU again, to decide for a specific task or operations. Okay, so these are very powerful software, SCADA, to monitor, to save data, to control what's going on, to acquire or to acquire or to plot the data, what's going on at the site, and in fact to instruct what the valve or the actuator should be do at the site, whether to open or to close in 5%, 30%, 70%. That is the capability of the supervisory control and data acquisition SCADA. Okay, typical component of SCADA system. Okay, we have a server. Of course, they need to be connected to a server in case we need to save the data in clouds. And then we have the brain, input output database. Okay, this PC, and then we have analog to digital. Okay, we have the instrumentation process control at one end, and then we have the transmitter receiver here, the transmitter receiver to this control room, which in this case a SCADA system. And then in this case, the communication is very important, to translate the input to the analog into the digital, and the digital into the analog, input and output. Okay, so the data will be transmitted to the transmitter receiver so that it can be monitored or collected by the computer. So in this case, it is not a wired system, it is a wireless system. As you can see here, they have the antenna, and then these are how this data will be transmitted to the control room. Okay, principle. Okay, the advantage of PLC, programmable logic circuit, or SCADA system. Okay, first you can see, of course, the computer can record and store a very large amount of data that is required for post processing procedure, or for monitoring procedure, or for post mortem of any fault condition. The data can be displayed in any way by the user, depending on the requirements. Means that we can view the data, we can process the data, and we can do whatever post analysis that is required. Okay, thousands of sensors over a wide area to be connected to the system, means that we are particularly looking at the sensors to send back the signals to the control room to decide what's going on site. And then we have the real data versus the simulations data. We can pump in the data from simulation into the real data, and vice versa. Okay, and many type of data to be collected from RTU, remote terminal unit. And then the data can be viewed from anywhere, not just on site, but we can actually view, if the data is stored on cloud, we can actually, the site is actually in the offshore, for example, and then the management officer at the Petronas KLCC tower still able to view the required data, not necessarily to be on site. Okay, that is the huge advantage of this system, communication system, or the monitoring and data acquisition system. But the downside of this system is actually the system is of course complicated, of course involving various device, various communication tools, various sensors, and many high-end device and equipments. Okay, it is not straightforward like we have if we have a gauge to measure or to give a reading of a pressure. Of course, uh, that is simpler. That is much simple. But we need this operation to be automate. We need to control remotely from anywhere we need. Then the conventional approach of the gauge on the system is no longer valid. Okay, and of course this one different operating skill are required. Okay, it might involve multidisciplinary fields. Some may involve in the instrumentations, some in control, some in programming, some are the computer, some are communication, and some are the data analysis. So we need to have a different type of group and people to work to achieve for the same objective. And of course with the involvement of thousands sensors and device, and then that will make the connection, the setting up of the structure will be much very complicated. Okay, so field bus, we come to the second category, which is field bus. Sorry, I just connected in this one. Okay, field bus is the communication, is a bi-directional communication, digital communication network. Bi-directional digital communication network that is specifically refers to the field bus that enable connection of multiple field instrument and process operated at the station. Okay, what are the key words for the field bus is actually it involved with the digital data. Okay, digital data, it allowed for uh, bi-directional going and coming, means that we are acquiring data from the site, and then we can actually send data from the control room to the site. Okay, so it involve bi-directional. Okay, bi-directional data for to enable the control room from the PLC to the instrument or device at the site. Okay, field bus, we type of the communication protocol use SCADA or DCS, distributed control system, DCS. Okay, we may need to use the Ethernet, profit bus, foundation field bus, device, and mode bus. Okay, these are type of the communication protocol. Okay, the language that is required. Okay, the instrumentation network design, the architecture. Okay, we have a network protocol which is into three categories, which is star, bus, and ring. Okay, star, bus, and ring. By looking at their names, of course, we know that this one on computer connected to the instrument in term of like this structure is called or is termed as star types, and then bus is B. This one is look like a bus anyway from the structure. It connected to a middle to the to one main path here. And for the ring, it is a ring types. So the actuator instrument they are connected in series in the loop like this one. Okay. Okay, so basically, how we differentiate this one in terms of the structure and how they connected to the control computer. Okay, how they connected to the PLC. Okay. Okay, instrumentation design network, again the communication architecture. Okay, previously we looked at the network protocol, and then now we look at the communication architecture. Okay, first we have the point to point. Okay, we have point to point between two device, two equipments. We have a control room here, and then we have RTU, remote terminal unit. Is either sensor, is either actuator, depending on applications. So this data is connected to the RTU directly, for a specific device, point to point. And we also have multi point architecture, multiple stations, and we have a relay station architecture. Okay, this is multiple point, RTU master, and then they are interconnected to each other, multiple. And the last one is actually the relay station architecture. In this case, we have the master here. Okay, we have the master RTU. We have the RTU 1, 2, 3, 4, and 5. We have a station here to store and to forward the data, and the master, that they are connected to this one. Means that uh, means that the device, the data from the RTU1 to 4 in this case will be transmitted to the main control system, and then in the main control system will transfer the data to a platform that is what we call relay station before it been feed to the RTU. There is one station before it goes directly to the RTU. Okay, this is the profit bus. Okay, profit bus. This is process field bus. That is what we call profit bus. Okay, profit bus, process. A field bus communication standard for linking field device to a programmable controller, HMI system or control system. So basically, it's a communication device again to connect between the device at the fields to the control room. These are some example of the communication. It's just a block of the communication tools for converting or for digital applications. Okay, profit bus. Okay, we have process field bus. We have a field bus message specimen. Okay, field bus message specimen, FMS, is used for, okay, we have three types. Okay, we have three types. Field bus message specification, FMS. This is a very general data acquisition system in which we acquire all sort of data. And we have a profit bus DP, decentralized peripheral. This one is used to operate sensor and actuator via a centralized controller in the production. For example, factory automation, application, and fast communication. Okay, so they communicate using the centralized controller. Okay, centralized controller. And Profibus PA, process automations, is used in area when intrinsically safe device and intrinsically safe communication are needed. Okay, process automation. So we want the process to be conducted automatically in the case that we need to give a priority due to health and safety. Okay, we have three types, or FMS, DP, and PA, decentralized peripherals and process automation. Okay, by looking at this illustration, we can see PA, what you call this one, process automation. Okay, we have a pressure, we have sensor, we have any gauge. This will feed data to the DP, centralized peripheral, PA third party coupler. So we have this one, and before it come to the general, okay, we have the DP field device, and we also have the compatible processor, or the brain of the system. All right, profit bars. Now, some advancement. If you can see here, there are very many devices available on market to be used, and they are very high tech. And I think that's about it for this industrial communication system. This uh, this topic is a complementary, is the additional, is the extra of what you have learned for from the chapter 1 to 5. These are just additional knowledge to you with regard to the instrumentation for process control. Okay, I think I've covered all for this chapter, very short, and we should discuss anything that is not clear in the class during your face-to-face or Google Meet session, so that we can further clarify what is, or what are the thing that is not, is confusing you. With that, thank you, and Assalamualaikum warahmatullahi wabarakatuh, and have a good day. Stop recording.